Hello everyone. So in this video lecture we are going to understand the basic terminology used in a graph and a basic definition that what is graph. So in a simple way a graph is defined as an set of V and E, right? So we can say that a graph G, it's a set of V and E, right? Now what is V? So this V represents the vertices, right? So it's a vertices where E represent edges, and these edges connect the vertices, right? Suppose I have multiple vertices. Let me give you one example that suppose we have a graph, uh, something like this. Randomly I'm giving this. So let us say I'm having something like this, right? So this is my graph G, right? For this graph, the V of G, that means the vertices, right? So what are the vertices I'm having? So that's A, B, C, D and E, right? This nodes, right? These are my vertices A, B, C, D and E, and the edges joining the vertices, right? These are the edges, right? So if I create a set that E of G, so that would be I'm having a path between A and B, right? So this is first edge, right? Then I'm having A and D, so that's the second one, right? So this is also done. Then I'm having B and C, B and D, then C and E, and D and E. So here all the edges are covered, right? So for this graph G, I can see that this is my V vertices, right? And this is my E, that is edges, right? So these a set of vertices and edges will create a graph G, right? Now this graph can be of two types. One that is directed graph, and the another one is undirected graph. Here what you are seeing, this example, that is an example of undirected graph, right? Because here we have not given the direction to the edges, right? In this scenario, see this A, I'm having an edge between A and B, right? So it might be from A to B as well as B to A, right? There is no direction, there is no a strict rule that this edge is going from A to B only or coming from B to A only. It's not like that, right? So what we need to do, this is undirected graph, right? Now suppose the same, if I want to represent it in a directed graph, so what I need to do, this A, D, B, C and E, in between that, suppose if I have an edges with a direction, right? So let us say this from A to B, then A to D, then let us say D to B, then D to E, right? Then C to B and C to E, right? So here my edges are representing the direction, right? So in this I can mention this is my directed graph, right? Here in this undirected graph I have that edge A to B, right? So in this scenario, this A to B and this B to A are same in indirected graph, right? But if I talk about directed graph, that A to B differs from B to A. This both are not same, right? A to B, that means I am having an edge from A towards the B, and B to A, that means I am having an edge from B towards the A, right? So this is the basic difference between the directed and undirected graph. Moreover, a graph is often viewed as a generalization of a tree structure, because like in a tree we have seen the parent-child relationship, right? So here also it's like a generalization of that. There is no parent-child relationship, right? But the tree nodes, like any kind of, they have the relationship between, like these are connected, these nodes are connected to each other, right? So this A is here, there is no scenario like that A is a parent of D or B is a child of A. No, it's not like that. But these nodes are connected to each other, right? Now if we talk about the terminologies used in graph, so the first one is adjacent nodes, right? And from the name itself you might be getting that what is adjacent nodes, right? Suppose I am having in a simple language, in our local language we say it's neighbors, right? So now you will get entire idea that what it is, right? Suppose I am having this, suppose I am having something like this, right? Okay, now if I talk about the adjacent node of A, so B and C are adjacent node of A, right? Then D and A are adjacent node of B, right? D and E are adjacent, D, E and A, these three are adjacent node of C, right? So these are the adjacent node, right? Now the second terminology that is commonly used, that is a degree of a node, right? This thing you have also learned in a tree, the degree of a particular node, right? So here the degree of node, that means the number of edges containing the node, right? So like suppose here in this scenario, if I have this A, B, C and D, so suppose I have something like this, right? So here the degree of B is 3. Why 3? Because it is containing this 3 edges, right? So B is containing 3 edges, so the number of degree for B is 3, right? For A, the number of degree is 2. Why? Because it is containing only 2 edges, right? Similar way, see, this is undirected graph, so you can have generally, right? For the directed graph, you need to take care of the directions. Like suppose I am having this from A to B, right? And then A to C, right? And here I have suppose D, something like this, right? So in this we have the concept of in degree and out degree. For a undirected graph, we don't have directions, so overall degree for a particular node is a number of edges, right? But here in a directed graph, there are two concepts, in degree and out degree. In degree, that means what? Number of edges coming inside, and out degree, that means number of edges going outside from that particular node, right? So here if we say that for a B, in degree is 1, because the arrow coming inside is 1, right? So in degree is 1 for B. In degree is 2 for B, because here D, this arrow is also coming towards, right? So 2 in degree is 2 for B, right? Whereas out degree is 0. right, for a B, because there is no arrow going from B, right. For a C, I can say that again for C also, in degree is 0, in degree is 2 and out degree is 0. For A, in degree is 0 and out degree is 2, right. Let us say that suppose if I change this from this to this, right. So now with the direction what I'll have, for A, in degree is also 1, out degree is also 1. For C also, in degree is also 1 and out degree is also 1, right. So I hope you understood the concept, right, that what is in degree and out degree, right. And there is also one term used, that is isolated node, right. Isolated node. Now what do you mean by isolated node? So isolated node, that means that node which have the degree 0, right. That means no in degree, no out degree. That means it's somewhere alone. Suppose I am having this graph and in that I am having this E over here. It is not having any in degree, not having any out degree, right. So this type of node is known as isolated node, right. Then next is path, right. Now path is what? So path is written as the length from a node, from one node to another node, right. And it is defined as an entire sequence, right. So suppose let me show you that, suppose if I have A and this, here I have D, right. Okay, now here I need to show the path between A to C. So the path between A to C is like I need to reach from A to C. So how can I reach? So if I go via D, right, so that is one possibility, is that A to D and D to C, right. So one path is A, D, C. The another path is I can go from A to B and then B to C. So another path is A, B, C, right. So this is known as a path, right. Then there is one more concept of cycle, right. Now cycle means what? That it is usually used in directed graph only, right. So cycle means what? That the path, whatever path you are having, right. So that path is, let me show you by example, then I can easily explain you. So I am having this nodes, right. Okay, so suppose if I have this kind of a scenario, something like this. Now here you can see that if I go start from A, I can go to B, then B to C, then again I can come from C to A, right. Now it's a circle, right. This A to B, B to C and C to again I can come to A. So this where source and destinations are same, this is a cycle, right. For this you cannot have the cycle. See, if I go for A to B, B to C, then C to D, I cannot go D to A. So it doesn't contain any cycle, right. If I go from this A to D, then I cannot go forward, right. So there is no cycle. But in this graph there is only one cycle, that is this A to B, B to C and C to A. That's one cycle we are having, right. So these are the basic terminologies that you should be aware of, because like in some algorithm you might be you might need that you need to check whether it generates in cycle or not. So first you need to have that concept that what is cycle, right? Yeah, then next one more, that is a weighted graph, right? Weighted graph, also known as labeled graph, right? This weighted graph, this weighted graph can be interacted or indirected, right? So if I go for the directed graph, so suppose I am having something like this, like a b and then this d, so I should have some c and let me add one more d, right? So suppose I am having something like this, I'm just randomly doing this, right? And here if I label something, some values, right, this value represent different things, right? So if I randomly add some values, that is known as a label, right, or a weight, right? So that represent that for reaching from a to d, it takes 2 unit, right? From reaching a to b, it requires 3 unit. From b to d, it requires 7 unit, right? So this kind of labeled graph are known as weighted graph. It is also known as labeled graph as well as the this labeled as well as the weighted graph, right? This cycle is also known as a loop. This thing also you need to keep in mind. This loop and cycle both are same, right? So yeah, these are the basic concept, or we can say basic terminologies, right, that are used in a graph, right? And also there in a directed graph we have two things, that is source and sink, right? So what is source? So a particular node is known as a source if it has all the out degree but no in degree, right? So let me show you here, that suppose I am having this something like a b c d, right? So suppose I am having this, right? Now here you can say, if you closely look at a is having, if you check the in degree for a, that's a 0, and out degree for a, that's a 2. That means all the edges are going out from the a, right? There is not any edge that is coming inside a, right? So this kind of node is known as a source node, where the in degree is 0, right? Then the next one is sink. So as you closely look at this d, right? So here if you check the in degree, so in degree for d is 2, but if you check the out degree, that's a 0, right? So when you have the out degree is 0 of a particular node, right, there are none of the edges that is going from d to somewhere, right? So this kind of node is known as a sink node, right? So that is a source and sink. This is also used in many of the algorithm, that what is source, what is sink, you should be aware of, right? So yeah, these are the basic terms that are used in a graph. So I hope you understood the basic concept of graph, that is what is graph, what is directed and directed graph, what is weighted graph, what is sink, source, what is cycle, and all those stuff, right? So in the next video lecture we'll understand the representations, even the algorithms, the traversal of the graph. So I hope you understood it. Thank you for watching this video.